All right, everyone, get ready for a deep dive. Today, we're going deep into some serious AI research.
Sounds intense.
Oh, it is. We're talking about the paper Enhancing the Reasoning Ability of Multimodal Large Language Models via Mixed Preference Optimization.
Okay, a mouthful.
But really, it's about something super important. Getting AI to reason, not just with words, but with images too. Like really understand what's going on in a picture, not just label it.
So we're not talking about AI that can just tell you there's a cat in a picture. We want AI that gets the whole scene, the context, the story behind the image.
Exactly. And here's the kicker. They're doing it all with open source models, meaning this powerful tech could be used by anyone, anywhere. Imagine the possibility.
ACT is huge in terms of accessibility and innovation, leveling the playing field a bit.
Exactly. Now, they're working with this open source model called Intern VL2. But get this, they found that when they try to make it use something called chain of thought reasoning, the AI actually does worse.
Oh, that's interesting. So making it explain its thinking actually hurts its performance.
Exactly.
Yeah.
It's like trying to explain a joke sometimes. The explanation ruins it.
Okay, I'm curious. What is chain of thought reasoning?
I'm going to let our expert take this one. It's a bit technical.
Sure. Imagine solving a math problem, but instead of just giving the answer, you show all your steps and explain your reasoning along the way.
So, showing your work.
Exactly. That's what chain of thought prompting encourages the AI to do. Show its work, so to speak.
But for some reason, this actually makes the AI less accurate. What's the deal with that?
Well, the paper talks about this thing called distribution shift. Basically, the way the AI learns and training doesn't quite match up with the way it needs to think for these real-world tasks, especially when it has to explain itself.
So it's like training for a marathon by only running on a treadmill.
Yeah, exactly. You hit the pavement and suddenly it's a whole different ballgame.
So the AI isn't getting the right kind of practice.
You got it. The training data isn't preparing it for this more complex kind of reasoning.
Okay, so what's the solution? How do you get the AI ready for the real deal?
That's where preference optimization, or PO, comes in.
PO. Sounds intriguing. Tell me more.
It's about showing the AI examples of both good and bad reasoning, like setting standards or best practices, almost like a coach mentoring an athlete.
So it's not just about giving the AI data. It's about guiding its development, shaping its reasoning ability.
Exactly, like fine-tuning its logical muscles.
I'm starting to see why this is so groundbreaking. It's not just about boosting accuracy. It's about making AI, I think, more like us, more logically.
Absolutely.
But there's got to be a catch, right? Nothing's ever that simple.
You're sharp. There's a big challenge, a lack of data. To really train an AI with this PO method, you need mountains of examples, especially for complex tasks like scientific reasoning.
So it's not just about quantity, it's about the right kind of data.
Right. It has to be high-quality, specialized data to really push the AI's reasoning to the next level.
Okay, so what do these researchers do? Where do you get that kind of data?
They got creative. They built their own data set.
Wait, hold on. They built a data set from scratch.
Well, not entirely from scratch. They developed a system to automatically generate this massive data set specifically for multimodal reasoning training.
Okay, now we're talking. They called it MMPR, right? Multimodal Preference Reasoning.
That's the one. And get this, it has nearly 3 million examples.
Wow. 3 million. Okay, now what kind of examples are we talking about?
Everything. General Q&A, scientific stuff, charts, math problems, even OCR and document analysis. It's a goldmine of data.
That's amazing. This MMPR dataset could be a game changer for the whole field of AI, not just for this one research project.
I completely agree. They've basically built this incredible playground for AI researchers to explore all sorts of new ideas.
So creating the data was one thing.
Right.
But how did they actually use it to train the AI?
They needed a new approach, a new algorithm, and that's where MPO really comes in.
MPO, the star of the show. All right, break it down for us. What's so special about this algorithm?
MPO is like a crash course in logic for AI. It teaches the model to do 3 things at the same time. First, it learns to judge the quality of different answers, to figure out what a good response looks like.
So that AI is becoming its own critic, evaluating its own performance.
Precisely, but it goes even deeper than that.
Okay, I'm hooked. How much deeper does it go?
It also learns to understand why some answers are better than others. It's about getting to the logic, the reasoning behind the answer.
That's pretty meta. We're not just talking about AI that solves problems, but AI that understands the principles behind those solutions.
Exactly. And finally, MPO helps the AI learn the process of creating those good reasoning steps itself.
It's like learning from from a master chef, not just copying a recipe, but understanding their technique, their philosophy.
That's a great analogy. And the results are impressive. They took the intern VL2 8B model, trained it with MPO, and the improvements were huge, especially on the MathVista benchmark. That's the one that really tests multimodal reasoning.
All right, I'm on the edge of my seat. How much of an improvement are we talking about here? Spill the beans.
Well, get this. The MPO-trained model, they call it intern VL2 8B MPO, it outperformed the original model by almost 9 points on MathVista. And hold on to your hat, it even came close to matching the performance of intern VL2 76B.
Wait a minute. That's a model 10 times its size. So they took a small model, trained it with this new method, and it's suddenly competing with the big leagues.
It's incredible. It really shows the power of MPO. It's like unlocking hidden potential within these smaller models.
And that has huge implications for researchers who might not have the resources to work with these massive, resource-intensive models.
Yeah.
It opens up a whole new world of possibilities.
Exactly, and it gets even better.
Oh, there's more. I'm all ears.
They did these really interesting ablation studies where they basically took MPO apart piece by piece to figure out why it worked so well.
So they were like AI detectives trying to understand the secret sauce.
Precisely. And they found some fascinating things. For example, combining MPO with some good old-fashioned supervised learning actually boosted performance even further.
So it's not about choosing one method over another, it's about finding the right blend.
It seems so. Like, a good education needs both textbooks and passionate teachers.
I like that analogy. So what else did they discover? Anything else about these different techniques?
They tested a bunch of different preference optimization algorithms, and some definitely stood out more than others.
Okay, give us the highlights. What were the key takeaways?
The algorithms that worked best were the ones that incorporated a reference model constraint. It's like giving the AI a role model, showing it what high-quality reasoning looks like.
Makes sense. Instead of learning from random examples, it has a gold standard to aim for.
Right. And in the end, the foundation of MPO turned out to be a combination of two specific techniques: DPO, which stands for direct preference optimization, and BCO, or binary classifier optimization.
Okay, you're going to have to explain those acronyms a bit.
Imagine showing the AI a bunch of finished Sudoku puzzles without ever explaining the rules. DPO is like hoping the AI will figure out the logic just by looking at the patterns.
So it's a bit of a trial and error approach.
Exactly. It can be really powerful, but it's not always reliable, especially for complex tasks.
So that's where BCO comes in. How does that help?
Think of DCO as providing a more structured approach. It helps the AI not just recognize good answers, but also understand the reasoning behind them. Like having a tutor who not only checks your work, but also explains the concepts.
It's about breaking down the thought process, making the logic explicit.
Precisely. And together, DPO and BCO prove to be the magic combination for unlocking the AI's reasoning abilities.
That's incredible. But here's the real shocker. Remember how this whole research project was about multimodal reasoning, teaching AI to think with text and images?
Yes, of course.
They found that training with this MMPR dataset, even though it's specifically designed for multimodal tasks, also improved the AI's performance on text-only tasks.
Now that is fascinating. It's like saying learning to solve jigsaw puzzles makes you a better writer.
It really challenges our ideas about how different types of intelligence are connected.
And it shows the potential of multimodal training to boost AI performance across a wide range of tasks.
So we're not just talking about AI that can understand images or text in isolation. We're talking about a more holistic intelligence, one that can integrate different types of information seamlessly. This is getting me really excited about the future of AI.
Me too. The possibilities are pretty mind-blowing.
Okay, so let's dive into those possibilities. What other amazing things could this research lead to?
Oh, the potential is vast.
Yeah.
Just imagine medical AI that can not only analyze x-rays and scans, but also reason about the findings, helping doctors make better diagnoses and treatment decisions.
It's like having an AI colleague, someone who can truly understand complex medical data and offer valuable insights.
Exactly. And what about education? Imagine textbooks that can actually understand diagrams and illustrations, giving students personalized explanations and interactive learning experiences.
That would revolutionize education. No more struggling to decipher complicated diagrams or feeling lost in a lecture. The AI tutor could guide you through the material, answer your questions in real time, and provide customized feedback.
It's like having a dedicated expert by your side throughout your learning journey, and let's not forget about the arts.
Oh yes, AI artists with a genuine understanding of visual composition and aesthetics, capable of creating breathtaking works of art that evoke deep emotions and spark meaningful conversations.
AI-generated art installations that challenge our perceptions and push the boundaries of human creativity. It sounds like science fiction, but it's becoming more and more possible with these advancements in AI reasoning.
It's exhilarating, but also a bit daunting. We have to acknowledge the potential risks as well.
Absolutely. As with any powerful technology, there are ethical implications we need to consider carefully.
We have to ensure that AI is developed responsibly, with a focus on fairness, transparency, and accountability. We don't want to create AI that perpetuates biases or harms society.
You're right. That's why research and open discussion are so crucial. We need to have these conversations now, while we're building these systems, to make sure AI is used for good.
So, to our listeners, we leave you with a challenge.
Oh, I like this. A challenge for our listeners.
Yes. Dive deeper into this world of multimodal AI and mixed preference optimization. Explore the MMPR dataset, think about the ethical implications, and imagine the possibilities.
The future of AI is literally in our hands, and it's up to all of us to shape it wisely.
Well said. But we've covered a lot of ground today.
And we have, and I think it's time for a little break.
Agreed. Let's take a pause, and we'll be back soon to continue this fascinating discussion.
Sounds good to me.
Welcome back, everyone. We're diving right back into our discussion about mixed preference optimization. And before the break, we were talking about all the incredible possibilities this research opens up. Like, where could this tech actually be used?
Well, one area that immediately comes to mind is medicine. Imagine AI that can not only process medical images like X-rays and scans, but also understand them, reason about them.
So not just identifying a fracture, but understanding the severity, the potential complications, even suggesting treatment options?
Exactly. It's like having an AI consultant working alongside doctors, providing a deeper level of analysis and insight.
That could be revolutionary for healthcare, especially in areas where access to specialists is limited. It could help level the playing field, bringing high-quality medical expertise to more people around the world.
Definitely. And this is just one example. Think about fields like engineering, where AI could help design more efficient and sustainable structures. Or finance, where it could analyze market trends and help make smarter investment decisions.
Or even the creative arts. AI that can understand the nuances of visual composition and aesthetics could create stunning works of art. Maybe even collaborate with human artists to push the boundaries of creativity.
Absolutely. The potential applications are truly mind-boggling. It feels like we're just scratching the surface of what's possible with this kind of AI.
It's exciting, but also a bit overwhelming. We have to be cautious about how we develop and deploy this technology.
You're right. It's crucial that we consider the ethical implications, ensuring fairness, transparency, and accountability.
We don't want to create AI that reinforces biases or makes decisions that harm individuals or society. It's a responsibility we all share: researchers, developers, policymakers, and even everyday citizens.
Absolutely. We need to have these conversations now, while this technology is still in its early stages, to make sure we're shaping a future where AI benefits everyone.
So to our listeners, we challenge you to engage with this topic.
Yeah.
To learn more about multimodal AI and mixed preference optimization. Explore the MMPR dataset, ask critical questions, and imagine the possibilities.
The future of AI is not predetermined. It's being shaped by the choices we make today. And it's up to all of us to ensure that future is a positive one.
Well said. But we're not done yet. We've talked a lot about the potential applications of MPO, but I want to dive deeper into the research itself. What makes this approach so effective? What are the key insights that have emerged from this work?
That's a great question. I think one of the most significant findings is the importance of combining different training techniques.
You mean like blending MPO with supervised learning?
Exactly. The researchers found that this hybrid approach actually led to better performance than using either method alone. It's like saying a good education needs both structured learning and hands-on experience.
I like that analogy. It makes sense. So it's not about picking one method over another. It's about finding the right balance.
Precisely. And another key insight is the role of reference model constraint in the preference optimization process.
You mentioned this earlier. It's like giving the AI a role model to learn from.
Yes. The algorithms that incorporate this concept tended to be more effective, especially when it came to improving chain of thought reasoning. It's like saying, okay, here's an example of what good reasoning looks like. Now try to emulate that.
So instead of just learning from random examples, the AI has a benchmark, a standard to strive for.
Exactly. And this, I think, is one of the most fascinating aspects of this research. It's not just about feeding the AI data. It's about guiding its development, shaping its cognitive abilities.
It's like we're not just teaching the AI how to solve problems, we're teaching it how to think.
Absolutely. And that's a profound shift in how we approach AI development. It's not just about brute force computation anymore. It's about cultivating a deeper understanding, a more nuanced grasp of reasoning itself.
And that brings us back to that unexpected finding we discussed earlier, how training on multimodal data, even though it's designed for tasks involving both text and images, actually improve the AI's performance on text-only tasks as well.
It's as if learning to process and reason about complex visual information somehow enhances the AI's ability to understand and manipulate language.
Like saying that learning to paint makes you a better writer. It challenges our traditional notions of how different forms of intelligence are connected.
It does. It suggests that true intelligence might be more about fluidity, about the ability to adapt and transfer skills across domains.
And this research really embodies the spirit of open source technology, which, as you know, is something we're both passionate about.
Absolutely. By making their models and the MMPR dataset publicly available, these researchers are fostering a more collaborative and inclusive AI ecosystem.
It lowers the barrier to entry for researchers and developers all over the world, allowing more people to contribute to this exciting field and explore the potential of this groundbreaking technology.
Imagine the possibilities. We could see a wave of innovation in areas we haven't even considered yet.
I'm particularly intrigued by the potential of MPO for scientific discovery. Imagine AI that can help us analyze complex data from telescopes, particle accelerators, or even climate models.
AI that could uncover hidden patterns and insights that would have taken humans years, maybe even decades, to discover. It has the potential to accelerate our understanding of the universe and address some of the most pressing challenges facing humanity.
It's not about replacing human scientists, but about augmenting their abilities, providing them with powerful new tools to explore the frontiers of knowledge.
It's about a partnership between humans and AI, each leveraging their unique strengths to achieve something greater than either could alone.
That's a beautiful vision for the future. But as we've discussed, it's crucial that we proceed with both excitement and caution.
Yes, we need to be mindful of the ethical implications to ensure that AI is developed and used in a way that benefits all of humanity.
It's a responsibility we all share. As researchers, developers, policymakers, and citizens, we need to engage in thoughtful discussions, ask critical questions, and hold ourselves and each other accountable.
The future of AI is not predetermined. It's being shaped by the choices we make today.
So, to our listeners, we leave you with this final thought. Explore the world of multimodal AI and mixed preference optimization. Dive deeper, question everything, and imagine the possibilities.
The future of AI is in our hands. Let's shape it wisely.
That's a perfect note to end on. Thanks for joining us for this deep dive into the world of AI reasoning.
Until next time, keep learning, keep questioning, and keep exploring the frontiers of knowledge.
Welcome back to the deep dive, everyone. We're wrapping up our exploration of mixed preference optimization and its potential to revolutionize AI.
It's been quite a journey, hasn't it?
It has. Before the break, we were talking about the ethical considerations of this technology, the need to ensure AI is developed and used responsibly.
It's crucial that we keep those conversations going. As AI becomes more powerful, we have to be incredibly mindful of the impact it has on individuals and society as a whole.
Absolutely.
Yeah.
We need to make sure AI is a force for good in the world, not something that exacerbates existing inequalities or creates new problems.
Right. We need to be proactive, not reactive. We need to think about the potential consequences before they arise and design systems that are aligned with our values.
And part of that is involving everyone in the conversation. This isn't just an issue for researchers and developers. It's something that affects us all.
Exactly. We need diverse perspectives, diverse voices at the table to ensure that AI is developed in a way that benefits everyone.
So to our listeners, we encourage you to continue this conversation. Talk to your friends, your family, your colleagues. Read up on the latest research. Ask questions. Challenge assumptions. Make your voice heard.
The future of AI is not set in stone. It's being shaped right now by the choices we make, the conversations we have, the actions we take.
Well said. And on that note, I think it's time to wrap up this deep dive.
It's been a pleasure exploring this fascinating topic with you.
Likewise. And to our listeners, thanks for joining us on the deep dive. Until next time, keep learning, keep questioning, and keep diving deep.